Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Functions make up almost 1/4 of the test questions. Standard 8.F.5. Use functions to model relationships between quantities. Describe qualitatively the functional relationship between two quantities by analyzing a graph. This is a very important standard, 3 to 4 questions on the test every year.
Hello and welcome. Here is what you need to know before we get to the examples.
What is an increasing function?
If y is a function of x, then this function is an increasing function. If as x increases, y also increases. And here are a couple of examples. This function here is linear, it's a straight line, and it's an increasing function. As x increases, y it increases, and the rate of change is the slope, and the slope is positive. This one is a nonlinear and also increasing. If you look at the graph from the left to the right, it's going up. It's going up.
What is a decreasing function?
Y is a function of x. Y is a decreasing function. If as x increases, y decreases. Here is an example of a linear and decreasing function. When you look at it from left to right, it's going down. And the slope is negative, which is the rate of change. And this is a nonlinear and decreasing function. Again, you look at it from left to right, and it's going down. It's going down.
What is a constant function?
A constant function is neither increasing nor decreasing. It stays constant. Here's an example. It's stayed constant. There is no rate of change. The rate of change is 0. The slope is 0. Okay, example number 1. The graph of a function is shown. This is the graph. Which statement correctly describes the graph? This is a very easy question. As you look at it, that's a decreasing function. It's a linear decreasing function. Look at the options he's giving you here. It says the slope is 0. That's not true. Slope is 0 is something that looks like this. So that's not correct. The slope is undefined. Undefined, it looks like this. Okay? And that's not the case for our function here. So that's not true either. The function is increasing. When you look at this here from left to right, is it going up? No, it's going down. So this one is also not correct. The correct answer is thus the function is decreasing. Example number 2. Carrie goes hiking on a mountain. The graph models her elevation over time. So at this point of time, she was at this point in terms of elevation, and obviously when you look at it, she's going down. Excuse me. So she's going down. So which statement best describes Carrie's elevation during the hike? So you look at the options they're giving us here. Let's look at one at a time. A decrease at a constant rate, which means linear, then no change in elevation. A decrease, that's fine. No change in elevation. She was taking a rest here. Okay. And then she continues going down. Then a decrease again at a faster rate. Yeah, this is a faster rate than this. This is a faster rate than this. So that's the answer to this question. Let's look at the other options. A decrease at a constant rate, which is true. Then no change in elevation for a while, that's true. And then a decrease again at a slower rate than before. Slower rate is like this. It's going to take her much more time to get to the ground. So that's also not an option. An increase at a constant rate, no. She wasn't increasing. That's decreasing. So this one is no, and this one is also no. Example number 3, Christy drives from Columbus, Ohio to Cincinnati, Ohio. Match each graph to the quantity which would best represent the value of y with respect to time x in minutes during Christy's drive. So Christy is going from Columbus to Cincinnati. So if you look at here the options, they are giving us that we need to fill up those here. The distance from Columbus. So what's happening to the distance from Columbus? As you are leaving Columbus, your distance from Columbus is going to be increasing. So that's where this will be the answer for this year. The distance from Cincinnati, as you are going to approaching Cincinnati, your distance is decreasing. Okay, so that's very straightforward here. Look at now at the amount of gas in gas tank. So obviously, as you're driving, the gas is being used. Okay, so it decreases the amount of gas. At one point here, you decided to fill up the tank. It goes up to here, and then as she continues her trip to Cincinnati, the gas is going to start diminishing. Okay. Example number 4. This one is a bit difficult, but let's see how difficult it is. An increasing function passes through x, y, and mn. I always recommend that you really look at read the question carefully. Increasing, that's a very important word here, an increasing function. Which statement correctly compares the 2 points? So they are giving me these options here. Let's go to do analysis of each one of these options. Let's look at the first one here. So x less than m, making small drawing here, x less than m, and y is less or equal than n. So y could be equal to n. In this case, this will not be increasing. Okay, this will not be increasing. Therefore, this option is not good. Option number 2, very similar. X is greater than m, but y is less or equal than n. So it could be equal to n, which means this is not a increasing function. So that's also is not a good answer. Let's look at C. C, if x less than m, y less than n. X less than m, y less than n. That's exactly what we meant by when x increases, y increases, and that means that's your answer. Look at the last one here. M is less than x is greater than m, and y is less than n. Here the function is decreasing, but my question here is an increasing function. So that's not good either. Example number 5. Which graph shows a function that is increasing at a constant rate? Increasing at a constant rate. Okay. So obviously you can immediately guess that this is your answer right here. That's an increasing at a constant rate. This one here is not increasing. That's a constant function. That's not increasing, not decreasing, so you can cancel it completely. This one here it's decreasing to this point and then increasing from this point up. This one here is a nonlinear, so obviously very easily you can guess the answer to be this. Example number 6. A car drives at a constant rate passing a store, a library, and a school along the way. A model of the car's path is shown. Here's the model, here's the store, here's the library, here's the school. And the car starting from A and going this direction. Match each building to the graph that models the distance from the car to the building over time as the car travels from point A to point B. So let's see here. So here obviously there's something that is going to be decreasing and then increasing. This one is decreasing, this one is increasing. So when you are here, if you look at the library, okay, the library, when you are here, the distance to the library is decreasing until you get pass by the library, and then your distance to the library is going to be increasing. So basically, that's this answer here. That's the library. That represents the library issue. This one here is decreasing. So the distance to the school is your distance to the school is decreasing, right? The distance to the school is decreasing. So that's your choice here. Here, from the store, when you are going away, so your distance to the store is increasing. Example number 7. Deidre has a new coin bank. For the first 5 days, she deposits the same amount of money into the coin bank. After that, she does not deposit any more money into the bank. Which graph could represent the amount of money in Deidre's bank? So if you look at this here, that's day 1, day 2, day 3, that continues. That's day 5 until it looks like there's more deposits are made. So that's not really the right answer. This one has nothing to do with just going up and going down. This one here is up to 5 here, and then at the 7th day, another deposit was made to make the account be equal to this. So that's also not good. If you look at this here, you see that in the first 5 days, the amount of money is increased by the same amount. And then after 5 days, nothing is happening, no more deposits. So the amount in the bank stays the same, okay? That's about it. Example number 8, Mario rides his scooter to the friend's house. His trip is represented in the graph shown, okay? Which statement describes Mario's ride? All right, so let's look at each one of these here. So Mario first stayed in one place and then rode at a constant rate. Did he stay in one place? That means that would look like this coming to here and then going up. That's not the case. So that's not a good answer. Mario first rode at a constant speed. Okay, constant speed, and then he stopped for some times. Did he stop? He did not stop. At this point here, he started speeding up more. Mario first rode at one constant speed and then at a faster constant speed. That is true. Like this, and then went faster. Let's look at the last option here. Mario first rode at one constant speed and then at a slower constant speed. That's not the case, okay? So this will be your answer, and we got it taken care of here. Example number 9. The cost of a product C remains constant over time. Remains constant. That's the constant function. And they want you to draw a sample of this function, just like that. Any horizontal line. The cost is over time stays the same. Example number 10. Which graph shows a zero rate of change? This example, you should not make a mistake of this. That's a zero rate of change, meaning the slope is zero. This one here is a negative rate of change. Slope is negative. This one here is not a function, okay? And this one here is not a linear. This is not a. This is a nonlinear function. It's decreasing up to this point and then increasing up from this point on. It's increasing. So that's your answer right there. Very simple. Example number 11. Which graph represents a function that is decreasing? Watch the words here. Decreasing, non-constant rate. Decreasing, non-constant rate. This one here is not decreasing, is not increasing, so you cancel this. This one here is decreasing at a constant rate because it's a linear. So yeah, that doesn't answer this decreasing at a non-constant rate. This one, your answer is that's decreasing, and non-constant rate meaning nonlinear, okay? And this one, obviously, this is an increasing function. It's increasing a nonlinear function.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.